Saxon Algebra 2. Greetings, my students. This is one of my favorite lessons. I love it so much. I can't wait to teach it to you. All right, we've been dealing with these things that we call quadratic equations. And we know that they look something like this. Here's an example of one. X squared plus x minus 2 equals 0. Okay? They have three terms usually, a squared, a plain x, and a plain number. And they're all on one side, and then we have 0 on the equal side. We like to solve these, don't we? We like to find out what can x equal. And the one way that we have been doing these the most is by what we call inspection, right? We look at this and we say, what are two numbers that multiply to this, add to that? And in this example, we can go, okay, it would be negative, positive 2, and negative 1, right? Because they multiply to this and they add to that. So then we would write it out as x plus 2 x minus 1, right, equals 0. We would have squeezed over there. And then we would say either x plus 2 equals 0 or x minus 1 equals 0. And we would do the algebra and we would say x equals negative 2 and 1. And that would be good. And that would be solving this quadratic equation. But here's the thing. Sometimes our quadratic equations cannot be solved by inspection. Sometimes we can't just look at them and find those two magical numbers because sometimes they're not cute little integers. Sometimes they're fractions or crazy radicals or even complex numbers. So what do we do if we can't just look at it and see? Well, that's what we're going to learn today. It's called completing the square. And we can use it for any quadratic equations, even easy ones that we could just look at and solve. It's okay if we don't notice that and we do this instead. That's fine. It'll still work. We can save ourselves some drama if we just looked at it. But this is fine. We can still use completing the square. Just so you know, there are a total of 5 different ways. And one time I was on a bus. I was on a community transit bus in the neighborhoods near my house, and I was sitting behind two girls that were clearly math students at Edmonds Community College. And you guys, they were having a conversation about which were their favorite methods for solving quadratic equations. And they were debating the pros and cons of each kind. I wanted to hug and kiss them both and tell them that I loved them so much because they cared so deeply about their math. But that's a different story. Anyway, we're on the second one. Again, this will work for all quadratic equations. It's not like you have to check, all right? It doesn't matter. Let's try it. It's got a lot of steps, so buckle in, put on your helmet, and let's check it out. Example 50.1. Solve x squared plus 6x minus 4 equals 0 by completing the square. First thing I do, check for standard order, standard form. This has to be arranged properly. It should be ax squared plus bx plus c equals 0, right? X squared, x, plain number, equals 0. Check. Sometimes John gives them to us messed up. This one's fine. Second one, kick C to the curb. What on earth am I talking about? All right, we want to get this C out of here. Now I could say swim it to the other side, but later I'm going to teach you something where this whole kick to the curb language is going to make sense. But in this case, that's essentially what we're doing is we're just swimming the 4 to the other side. And I'm going to have x squared plus 6x. Now notice this makes 0. Leave the gap. Okay, when we swim that C to the other side, when we kick it to the curb, That will create a gap, right? Because that comes to 0. Leave the gap because that's going to be helpful. 3, fill the gap with what I like to call the magic number. Where do we find a magic number? I will tell you. We're going to calculate it. This, remember, is B, right? We take this number, B, we divide it by 2, and we square it. And we draw an arrow to what's inside the parentheses for reasons that will become obvious later, all right? So B is the number that's in front of the X term. It's the survivor after we kicked C to the curb. It'll be right in this place. So in this case, it'll be 6 divided by 2, which is 3. I draw the arrow. 3 squared equals 9. Now, add to both sides. I lost points on a math test once because I forgot to add the magic number to both sides. In order to keep this puppy in balance, we have to do that, right? That's just basic algebra. So if my magic number is 9, then I want to add it here, and I also have to add it here. I'll underline it just to highlight that for you. Okay, now I'm going to come way down here. The 4th step is to write the left side as a perfect square. Okay? What we have done is created this so that it's a binomial times itself. It'll always work out that way. How do we know what that binomial is? We look right here. You see how I drew this arrow? That's the number. This number goes right here, and we can check it by writing it like this. Okay? We're saying that we completed a perfect square here. We know that it should look like this. It should have 3s because that's the number that's inside the parenthesis. We can write it like this, and that helps us check, right? Because if we're multiplying these, then these two should multiply to get this term. 3 times 3 is 9. These two should add to get this term. 3 plus 3 is 6. Beautiful. So we write it this way to check it, and then we can simplify it like this, and then we can fix the other side. Does that make sense? This is one of the weirdest parts. The magic number is okay, but how do we get from the magic number to the binomial squared? This number helps us do it. And we can write it out and check it just to be sure. But this one checks. Okay, so now I'm going to rewrite this in this format because now we're just going to use algebra to solve it. And we practiced this just a few lessons ago. You may have forgotten. But the way that we do this is we take the square root to counteract that squaring. And so we get x plus 3 equals plus or minus the square root of 13, right? We have to do plus or minus because if you're squaring things, then 2 negatives will make a positive. So negative square root of 13 is an answer we have to consider. And now the last step is to get rid of this 3, so our x is by itself. So the answer to this problem is that x equals minus 3 plus or minus the square root of 13. That's the value for x that will make that come true. Which is kind of mind-blowing because this doesn't look very complicated. That answer looks crazy complicated, but that's just the way it is. And no wonder we couldn't solve this by inspection because who would have ever guessed that number, right? Now, I'm going to write this here. For step 4, I'm going to write remember plus or minus on the right. That's something that students often forget is to take both the positive and the negative. These are the steps. They're long, they're complicated, they're somewhat annoying. We're going to practice this and get better at it, but later we're going to learn another technique for factoring, solving quadratic equations that will not require so many steps because mathematicians realize this is kind of a pain. It works, but good Lord, how many steps? We're going to practice them, we're going to get them down, and then we'll learn the shortcut. Got it? Okay, so here are the steps. I'm going to speak them over and over. I'm not going to write them out every time. So make sure you pause now and get this really clear in your notes. Example 50.2. Let's do another one. 2x plus x squared minus 5 equals 0. If you felt panicky when you noticed that, you were right. John has messed with us. He did not put it in standard form. He mixed these up. So let's fix it first. X squared goes first, then the 2x, then the minus 5. Ha! We don't need your nonsense, John. We can fix it. Next step is to kick this to the curb, the c value. We're going to have x squared plus 2x. We're going to leave this gap, and there's 5 kicked to the curb. Magic number. I'll remind you of the formula for that. We take the b value, we divide it by 2, we draw an arrow to that, and then we square it. So in this case, that will be 2 over 2 squared. 2 over 2 is 1. 1 squared is 1, so our magic number is 1. So we'll add 1 to both sides, no drama. And then we know that we can write this as a pair of matching binomials. The number inside the parentheses is what goes there, and we can write it as x plus 1 quantity squared. But this way is helpful to make sure that we got it right. These two should multiply to this. It's the same rule we use when we do factoring by inspection. The numbers here should multiply, and the numbers here should add. And it works. So we know we did it right. This equals 6. I add the 5 and the 1 together. Okay? So we want it written in this form so that we can take the square root, but we write it like this first so we can double check. All right, take the square root to neutralize. X plus 1 equals, remember our plus and minus. Square root of 6, is there anything we can do to simplify here? No. And so our last step is just to isolate that little x equals minus 1 plus or minus the square root of 6. Remember that this represents two numbers. We could take minus 1 and add the square root of 6, or we could take minus 1 and subtract the square root of 6. So that represents two values for x. Yay, that's the right number. And we just have one more to do. Example. I'm trying to decide if I want to squish it into the space. Let's do it. 50.3. Solve. Now I can see John gave us a mixed up form, right? X squared equals 5x minus 5. No. I'm going to swim everything over to the left, and I'm going to change the signs as I change the sides. So that will become x squared minus 5x plus 5 equals 0. Okay, standard form, check. Kick to the curb. X squared minus 5x, leave the gap, equals minus 5. Magic number, it's b. Now put the sign in there too. The minus 5 over 2 squared. Draw your arrow, square it. Now this looks scary because we have a fraction here. We didn't have scary fractions before. It's okay, just square it, don't worry about it. 5 squared is 25, the negative goes away. 2 squared is 4. That's our magic number. Don't be afraid of it. We add it to both sides. That's going to be a mess to add, but we'll deal with that later. Now, trust me on this. The binomial that goes here is x, and then whatever's inside the parentheses, minus 5 over 2. Let's check that. If we multiply these together, they should equal this. The negatives become positive. 5 times 5 is 25. 2 times 2 is 4. That works. Now they should add to this. Minus 5 over 2, minus 5 over 2. To add them, the denominators match. So we would say it's minus 10 over 2. And minus 10 over 2 simplifies to minus 5, right? This becomes minus 10 over 2, which is equal to minus 5. All right, so these work. This checks out. So now we can write it in the other form because it's good to go as a square. Equals, now we have to clean up this side. This needs to have a 4 on the bottom, so it's going to equal minus 20 over 4, right? Minus 5 equals minus 20 over 4. And then we are adding these. There's my plus sign. It got kind of squished. So that becomes 5 over 4. And now we're just about there, aren't we? We're going to take the square root of both sides. So we'll get x minus 5 over 2. Those two cancel each other out. Equals plus or minus. Now this is always going to work this way. The top is hopelessly embroiled in a pig house. We can't get that 5 out. But 4 is a perfect square, and it will always come out of the radical sign. So this is going to be plus or minus square root of 5 over 2. There are mechanical reasons why it will always work out that way. I'm not going to explain it to you now because your brain is already bursting, I can tell. But I want you to know that the denominator of whatever we make over here on the right will always jump out of the radical sign as a nice, cute number. And then our last step is just to add whatever's bothering the x. That cancels, and we get x equals 5 over 2 plus and minus the square root of 5 over 2. And that's the way we like to write the answer. Sometimes John will squish that together because it is one fraction, right? So we could squish it, but I much prefer to leave them separate for reasons I'll explain later. Completing the square. If there is anything left of your brain at this point, congratulations, you're doing very, very, very well. We're going to do this a lot. I promise you there will be a review problem on it because it's always important to practice it. Stick with it. Trust me, students always hate it in the beginning, and then sometime around Valentine's Day, they'll be like, oh, completing the square is so fun. And I'm like, yes. All right, lesson 50. Oh my gosh, it just makes me so happy. We're done. Okay, thank you, goodbye.